A random sample of 32 men and 30 women in a college class reported their grade point averages. The men had a mean GPA of 2.83 with a standard deviation of 0.5. The women had a mean GPA of 3.2 with a standard deviation of 0.45. Test the claim that the women have a higher GPA than the men. Let alpha equal 0.05. How are we going to approach this? We first have to realize that we are working with means. And we need to sort out that we have more than one sample. And as you notice, we were given full information about the men, their mean and standard deviation and sample size, as well as full information about the women, mean, standard deviation, and sample size. With this type of information, we will say that we have two samples. Now, how will this look as hypothesis statements? Well, certainly we will have mu's in our hypothesis statements, and we'll have two of them. Means is the answer to your first question, and two. So your hypothesis statements will have two mu's in it. We also want to consider that we want to test the claim that the women have a higher GPA than the men. So we'll have to think about what our alternative will look like. Here you can see the two means are in the hypothesis statements. I'm just using subscripts of W and M rather than 1 or 2 so that I can keep up with women and men. And as you can see here in my alternative, both the women again and the men, women on the left, men on the right, and I'm using a greater than because it wanted us to test if their GPA is higher. Another way you could write this is this way. If you notice over here, it's the same hypothesis statements. Certainly the null looks the same with the equals, but notice I reversed the order. I listed the men first and then the women. And in doing that, the inequality would then flip over so that the larger side of the inequality is still faced towards the women. Either hypothesis statement is fine. For simplicity reasons, I'm going to choose the one on the left and work our problem with that set of hypotheses. Before we jump into StatCrunch and try to get some solutions here, let's consider our assumptions and conditions. As with a lot of our other hypothesis testing, we have to have the assumption of randomization. So we need to know that both samples are random samples, and indeed they are. Independence. We're going to need to feel comfortable assuming that the women and the men are in no way connected to one another in these samples, that they are what we call independent. The two samples are independent of one another. And lastly, we want to make sure that our N is big enough. So both samples need to have 30 or more. Let's organize our information. There's a lot of numbers given to us within the text of the problem, and what I'm doing with this slide is just organizing it. Putting a little table together with women and men and putting down the mean, standard deviation, and sample size for each. This will be helpful when I enter this into a software package. And here comes our software package. Again, keeping two samples straight and computing with two samples leads to some long, tedious hand calculations. Now I have that information below this video in your module, in your lesson, but if you want to see how one does this with software, here it goes. So you'll go to StatCrunch and open my StatCrunch so you get to your nice spreadsheet page. We're going to go to Stat, T-Stat because we're working with means, two samples because we're working with two samples, men and women, and we have a summary of those two. So sample 1, sample 2. Sample 1 will be the group that you put on the left side of your hypothesis statements. In our case, those are the women. Their mean was 3.2. Their sample standard deviation was 0.45, and they had 30 in their sample. Let me double check that with my little list I made. 3.2, 0.45, and 30. Excellent. Now let's enter sample 2, which are our men. 2.83 was their sample mean. Get that 2 in there. There we go. 0.5 was their sample standard deviation, and they had 32 in their sample. I am going to turn off the option that says pool variances. I'm going to turn that off for this problem. And we're going to leave the hypothesis, the number in the hypothesis, as is. Now we have to think about this. Our null hypothesis says that the men and the women have equal GPAs. Now consider, if you're subtracting two things that are assumed to be equal, this is kind of how the hypothesis is written here in StatCrunch. Two things that are assumed to be equal, if I were to subtract them, I would expect the difference or the solution to be 0. That is why 0 is here. We will not touch that in StatCrunch. We will, however, situate our alternative hypothesis to be greater than, as it was written on the beginning of the problem. So we're going to hit compute. Here is our solution. 3.066089 is our t-stat, and 0.0016 is our p-value. Now if you look here, it reminds you that population 1, population 2, here's our hypothesis again, and more importantly, here are our t-score and our p-value. So if I take the information from StatCrunch, I've just typed it here into the slide so that you can remember what the t-stat was and the p-value. Again, 3.066, a p-value of 0.0016. So again, a large t-score coupled with a small p-value. This is quite often, the further one is out on the curve, the smaller area you would accumulate in the right tail. So what's our decision going to be? Our p-value is indeed smaller than or less than the significance level we were given for this problem. Think a minute about what that means as far as the decision. That's right, we're going to reject the null hypothesis because our p-value is less than alpha. So think about it as we start to want to formulate a statement. These were our original hypothesis statements. Our testing led us to the conclusion to reject the null hypothesis. Here it is, I've sliced it and crossed it out. So what are we left with? The alternative. That's all that we have. Once the null hypothesis has been rejected or disqualified, we have to lend our support to the alternative. Now, what does the alternative say? We leave the testing process with a conclusion that says that the mean GPA of the women is greater than the mean GPA of the men. Let's make a sentence. The sample data suggest that the women at this college have a significantly higher GPA than the men. Again, exactly what we were left with our hypothesis statement. The women have a higher mean GPA than the men.